Hey, sixth graders, the second half of this unit is going to be about probability, and probability is the measure of how likely an event is to occur, or in other words, it's the likelihood of things occurring. So in general, with probability, we measure likelihood on a scale from 0 to 1, and 0 means it's a 0% chance, which means it's impossible. 1 is a 100% chance of something occurring, which is certain. So if I told you there's a 100% chance it's going to rain today, how would you react or respond? You would bring a rain jacket or an umbrella because you know for sure it will be raining today. And 0.5 is a 50% chance. So if we go ahead and think all the way back to the beginning of the school year, when we related fractions, decimals, and percentages, this is 0.50. And in order to turn that into a percentage, we shift it twice to the right. So that is a 50% chance of something happening, which means you have an equal chance of it happening as equal as it is of not happening. So in general, with probability, the way we figure out what percentage something is to happen is we put the number of favorable outcomes or the number of outcomes of things you're looking at, and you compare it to the total number of possibilities there are. So it's a lot of fraction work that we will be turning into decimals and percentages. So it's really just trifecta work. So again, I'm going to be asking you questions like, what's the probability of rolling an even number on a die? And you would figure out, well, how many even numbers are there? That would be your numerator, and your denominator would be the total number of numbers on a die. So let's talk about this idea of theoretical probability and experimental probability. So theoretical probability, the stem of the word really gives it away. It's what should happen in theory. It is what should happen in theory. I don't know if I spelled that right. Theory? Theory. Yes. No E. Sorry, I think. Anyways, I'll look that up later. Experimental probability is what actually ends up happening. So a very basic example for you. Let's talk about flipping a coin. You have heads and you have tails. So you have a 50% chance of flipping a heads because there is one heads out of two possible outcomes. So that's 1/2, which is 50%. So in theory, if I were to flip a coin 20 times, in theory, I should get a heads 10 of those times, half of the time. So that would be the theoretical probability, but the experimental is what actually happens. So as we all know, things don't always happen the way they're supposed to. So whatever I end up flipping, let's say I actually flip 12 heads, that would be my experimental probability. It's what happens when you conducted the experiment. So let's go through some examples. We're going to be taking a look at cards and spinners and dice. And the first thing I want to point out to you is some notation here. So P and then parentheses of something, that means probability of a B. So we're looking at the top half here, and we have all of these cards. So what is the probability of selecting a B? So again, the first thing we want to do is take a look at how many possible outcomes are there for the thing we're trying to get for a B. There's one single B. So 1 is your numerator, and there are 1, 2, 3, 4, 5, 6, 7, 8 total possible outcomes. So the probability of selecting the letter B is 1/8. It does tell us to write it as a fraction, decimal, and a percent. So let's go ahead and do that. So this is good review of our trifecta work. You have two ways of turning fractions into decimals. You can turn it into a base 10 denominator if it works nicely. In this case, it will. And then when it doesn't work nicely, you can always divide the numerator by the denominator. So I'm going to go ahead and, I don't know if you remember this from way back when, but if you multiply 8 by 125, you get 1,000. So this is 125 thousandths, which is 125 thousandths. And as a percentage, if I shift the decimal twice, this is 12.5%. So you have a 12.5% chance of selecting a B, which means you really don't have that big of a chance. So if I were betting money on selecting the letter B, if these were all flipped over and I didn't know what the cards were, I wouldn't place a lot of money on it because there's not a super huge chance that you would select just the letter B. Let's take a look. What's the probability of selecting a Q or an R? Okay, so again, we're going to take a look at, well, what are the favorable outcomes? How many are there? Well, we have one Q and we have one R, so that's 2 possibilities. So this is 2 out of 8 total possibilities. So this is 2/8. If we reduce that, and it's a quarter. And I hope we all know by now, a quarter is 25 hundredths, which is 25%. So a much greater chance of selecting a Q or an R. And what is the probability of selecting a vowel? So we have A, E, and O are the vowels in these letters. So we have 3 options out of 8 total. I'm gonna go ahead and, actually this time I'll go division route just to go through an example of that. So remember, we can always turn fractions into decimals by dividing the numerator by the denominator. So we got, that goes in 3 times, minus 24, that's 6, bring down the 0, that's 7 times. Bring down another 0, we keep going. Okay, so it is 0.375, which is equivalent to 37.5%. So if you had to place a bet dealing with money on selecting just a B, or selecting a Q or an R, or selecting a vowel, you have the highest chance, 37.5% is the greatest, of selecting the vowel. All right, let's go ahead and take a look at a spinner example. So we're talking about just spinning the spinner once. What is the probability of spinning it and it landing on a dog? Well, let's see, we have 1, 2, 3 dogs out of 6 possible options. That's equal to a half, which is equal to 0.50, which is equal to 50%. So you have a 50% chance of spinning and it landing on a dog. The probability of a hamster, well, that's just 1/6. 6 cannot be turned into a denominator of 10 or 100 or 1,000, so we have to go division route here. So 1 divided by 6, add some zeros. Oops, that's 4. That goes in, let's see, 6 times, minus 36, 4. Okay, I'm gonna keep getting 40, which means I'm gonna keep getting 6. So that is 0.166 repeating, which is 16.6 repeating % chance of spinning and it landing on the hamster. All right, and let's take a look at the probability of a cat or a dog. So if it lands on either one of those things, we're good to go. So how many options are there? 1, 2, 3, 4, 5 out of, 6 total options, not 8. Sorry, I was getting used to the last problem. So 5/6, so now I need to divide 5 by 6. Let's see, 8 times, minus 48, 2, bring down the 0. That goes in 3 times, minus 18, 2, 0 again. Okay, it's gonna be 3 repeating. So this is 0.833 repeating, which is 83.3 repeating %. So you have the greatest chance of spinning and it landing on a cat or a dog. Let's do a couple more examples. And then I'll leave the bottom part, which is another spinner problem, for you to try on your own and check the answer key. So what we're taking a look at is theoretical versus experimental probability. So a number cube is rolled 50 times and the results are shown in the graph below, okay? So after all of these 50 rolls, we got 10 ones, 8 twos, 6 threes, 9 fours, 5 fives, and 12 sixes. So what is the experimental probability of rolling a 2? So remember,